Hello folks, we're back again. We're ready for Unit 3, Homework Demo Video 7. Two really important concepts being covered in this video. Solving formulas for one variable and absolute value equations. So let's get this started because we are going to be busy. First, we're going to look at some formulas here, and we're going to use these formulas later. We'll solve the formula for one variable or another. So here is a formula you should be familiar with. If you are not, you need to be looking at your resource guide for the EOC exam because you will see all of the formulas we use today, or most of them, on that sheet. How do you use a formula? Well, oftentimes you're giving several values. In this case, this says that the volume of a cylinder V is always going to be equal to our constant pi, remember pi is a constant because it's a number, times r squared times the height. Then you're given a number for pi, a number for volume, and a number for the radius. So let's plug those numbers in. Well, our volume is 235, so instead of the V, I'll put in 235. Then I keep my equal sign, and they tell me pi is 3.14, so I'll put in 3.14 for that. Then they tell me my radius is 5, so I'll put the 5 in, and notice I have to square it because the formula says I should square it. And then they want me to find the height. Can I do that? Of course I can, just a little bit of math. I'm going to multiply all these guys together here first. So 5 squared, thinking about PEMDAS, I have to go 5 times 5, take care of my exponent first, times 3.14, and I get 78.5 times my height would equal the volume of 235. I know that since the h is being multiplied by 78.5, if I divide both sides by that, I will solve for h, and that's what I'm trying to do here. So what is 235 divided by 78.5? And I get h is equal to 2.99, so just about a height of 3, depending on how they wanted me to round it. Let's look at another formula down here. This formula is for simple interest. So it stands for this. The amount of money in your account A is equal to this large P. It stands for the principal, how much money you put in the beginning, times the quantity, 1, plus R is the rate that you're getting paid at, and T is how much time you leave it in the bank. So all we're really doing, we don't even have to really understand that. We simply need to plug in the values that we know. We know A, we know P, and we know R, and we're going to end up solving for T. So let's get those numbers in there. A is 168. That is equal to our principal, 150, times the quantity, 1 plus R is 0.08 or 8%, and T is time, and that's what we're being asked for. Find T. So we'll leave that T in there. So I need to now solve this equation for T, and what I see in it is the distributive property. So I see that 150 needs to be multiplied through here in order for me to solve. I'll leave the 168 equals 150 times 1 is just 150, plus 8% of 150. So now I need my calculator, 0.08 times 150, and I get 12. So it's going to be plus 12 T, because 150 times 0.08 is 12. Now I'm doing just a two-step equation, right? I have to get rid of the 150 on both sides, and 168 minus 150, I think I can even do that in my head, is 18, is that right? Yep. And 12T comes down. How do I solve for the T? And now divide by 12. And I have to go over here to say T is equal to 18 over 12, which I'll put into my calculator and say I get 1.5. So how much time? It's 1.5, and I happen to know that's 1.5 years because this formula on interest always works in time is equal to years. So 1.5 years after I put that money into the account, $150. 1.5 years later, I'll have $168 if the interest rate I'm getting is 8%. That's what that is telling me. So pretty much those are both using formulas. Here's another couple that we can use formulas on. Again, you'll see these formulas in your resource guide. You'll find that in dot sharing. This time I want to know what's the area if I have this trapezoid and base 2. By the way, these are our bases, base 1, and they can go either direction. And this is base 2, the parallel line to the trapezoid. And then the height is how tall it is from here to here, which you can't see because I'm writing in red, so how tall it is from here to here. All we're really doing is finding the area is 0.5. Whoops, you know what I just realized? I don't have enough information in this problem. The area of a trapezoid A is 0.5 times base 1, which is 14, plus base 2 times the height of 8. So what happened here, and I'm just going to leave it at this after I explain, they didn't give us enough information, or I should say I didn't give enough information when I wrote the problem. Notice that I left 2 variables in here. And because I left 2 variables, I can't solve the equation. So I think what I'll do is add in one more piece of information. Let's pretend that they gave us all the information we needed, which means they told us that the area of our particular trapezoid equals, and I'm just going to pick a number, 100. Let's say the area equals 100. Then what would this base 2 be? In other words, I'm giving us enough information to plug in 100 for our A, and then we're going to solve the rest of this to come up with what's our base. 2 times 8. So what I'd like you to see is that you have 2 numbers here that need to be multiplied together. And they're both outside the parentheses. So to start this equation, we can say 100 equals half of 8, or 4 times 14 plus B2. So I took the 2 numbers, even though they're on the other opposite sides of the parentheses, they're both on the outside. So they get multiplied together first, then we can multiply them through this way. So now we have 100 is equal to 4 times 14. And I don't want to mess it up, so I'm going to go 4 times 14 and get 56. And 4 times B2 plus 4B2. Little b on the bottom just says sub 2. I think to solve this, I need to subtract the 56. And I'm going to do this without writing it all down. I'm going to subtract the 56. Then I'm going to divide by 4. So it's 100 minus 56. That answer divided by 4 tells me that the base 2 must be 11. So I solved in my calculator without showing my work and got that this B2 is equal to 11. Solved this guy right here. To kind of mark it up, what it did do is it showed you that if I'm given a formula, then I need to be given all the information except one piece. So in this one, I didn't give you enough information. I had to come back in and fill it in. You can't solve an equation unless you can get it down to one variable. Let's see if I mucked this one up or did better. The formula for surface area of a cylinder is 2 times P times R times the quantity R plus H. We're given, and this is a weirdo too, we're given that the area, and this is going to be 40 P. So I'm just putting into that A right there, and that's going to equal 2 times P times R, but they're telling us that our R is 8. So I'll put in 8 plus H, and they're asking us to solve for H. But this time, they're saying we can solve, and there's going to be a P involved in the answer. So let's see how that works out. 40 P, and again, I have to do the distributive property to get 16 P plus 2 PH, and that's this multiplication right here. I need to solve for H, So I need to get rid of 16p on both sides. How do I know I'm solving for h? Because it tells me right here, find h. So 40 minus 16 is going to be 24p, and that equals 2ph. And watch, I'm going to divide both sides by 2p. The p's go away, 2 and p go away here, and I get h left over on one side and 12 on the other side. So my height must be 12 if my radius was 8 and the area was 40p, which they gave us in the beginning. Kind of crazy, lots of variables, but really you're plugging in for every variable and then solving for one. Unlike these guys. These guys are solve the equation for x. So if we look at this equation right here, we notice that it has two variables in it, both an x and a y. So it looks funky, but we can still get x by itself. What we say is we're solving for x in terms of y. In other words, we don't know what number it is, but we know what number it is if we know what y is. So here's what we need to do. We're trying to solve for x, we do what we always do. We look at what's sitting beside it. Well, in this case, it's a 15y, in particular minus 15y. So what if I add 15y to both sides? Do that over here. And the reason I'm doing it is I'm trying to get the x by itself, right? So I need to get rid of this, and I have it down to where I now have 3x. Now be careful over here. I can't add 20 and 15y. All I can really say is it's 20 plus 15y. They're not like terms. I can't combine them. I still need to solve for x, though. So I'm going to divide by 3. And when I do that, I need to divide each piece. So notice I'm writing it 3 times to make sure I divide all 3 pieces by that 3. When I divide here, I get x. I'm going to come write my answer up here. 20 divided by 3, not a lot I can do with that. So I'm probably just going to leave it as 20 over 3. It doesn't really reduce. 15 divided by 3 is simpler though. 3 goes into 15 5 times, so I can simplify that to plus 5y. Now, you might see as your multiple choice answer 5y plus 20 over 3. You might even see it as a mixed number or a decimal, but probably they're just going to leave it as 20 over 3. I just want to point out, because it's addition, you can write it in either direction. We have now solved in terms of, solved for x. X is by itself in terms of y. We don't know the number for x, but we know it in terms of y. If we knew y, we would know, we would be able to find it. Let's try that again for this one. We need to solve the equation for p. Although obviously something's mucked up, I can't solve this equation for p. There's no p in it. I'm going to nix that one and go to the next one. Let's solve this guy for y. Now we're going to take this equation and get y by itself because we were asked to solve for y. So what do? I get rid of the 6x in the same way I did in the equation above by subtracting it away. I'm left with 2y equals negative 24 minus 6x. And notice I cannot put those together because they're not like terms. Sorry. Now I need to divide by 2 to get that y all by itself. Again, divide both pieces by 2. So what do I end up with? I'll go over here. Y is equal to, and this is my y right there, all by itself now, equals, I have a negative 24 over 2. I'm going to change that to negative 12. And then I have minus 6 over 2, and I'm going to change that to 3. And there's a variable by it, which I can hardly read. Is it the x? Yes, it's the x. So it's going to be minus 3x. So what have I done? I've solved for y in terms of x. I got y by itself and got x on the other side. I have one more down here I could do, except look, I mucked it up too. I say solve for m. Sorry about that. So when you're solving for one variable, you're doing the same thing you do when you're solving, when you've got all numbers, except you have to be careful not to add terms that do not match. One more thing we have to deal with in our lesson today, and that is absolute value equations. I know they do a lot into this lesson. Sorry about that. If you recall, and I'm just going to back up and remind you, you remember that the absolute value of 2 is equal to 2, but that also the absolute value of negative 2 is equal to 2. So in other words, absolute value means make it positive. So if we're trying to solve an equation like this one right here that involves an absolute value, we have to remember that, well, it could be positive or negative inside there, and it would come out with the same answer. So the way we take care of that is this. We write the equation 2 times, once for each of these scenarios. The first time I write it, I take the absolute values are, and I take the absolute value bars off, and I simply say x is equal to 2. The second time I write it, I take the absolute value bars off, but I change the sign of the guy on the other side. And I say, well, it might be equal to negative 2. Not that hard, right? That one came out pretty simple. There are 2 possible answers. If the absolute value of x equals 2, then it must have been either a 2 that was inside there to give me the 2, or it could have been a negative 2. It could have been either of these 2 things. Let's do that when it looks more complicated right here. We still do the same thing. First of all, we say, well, either m plus 7 equals 15, or, this is the second time I write it, m plus 7 equals negative 15. There are 2 equations. If I solve the 2 equations, I will get 2 different answers for what m might be. Here, m is equal to 8. 15 minus 7 is 8. Or, it's possible that m would be equal to negative 7 and it's 12, 22. These are the 2 answers that m could be if m minus 7 is equal to 15. And I think if you plug these into there, you'll see what I mean. Let's just do that. What if m were 8? Then 8 plus 7 would be 15. The absolute value of 15 is 15. What if I put a negative 22 in there? Then it would look like this. It would be an 8. It would be a negative 22. And when you add together negative 22 and 7, you'll get negative 15. Absolute value of that is 15. So again, when we have an absolute value equation, we're going to have to separate it into 2 separate equations. I'm going to write the 2 equations for this last one, but probably not solve it. What are the 2 equations we write? The first one, 2n minus 4. Just remove the absolute values, leave it alone. That's all I do. Now solve that and solve one more equation, 2n minus 4 equals negative 12. When you solve those 2 equations, you'll have the 2 answers that will work in this equation. Absolute values have 2 different answers. They get a little bit more complicated here. I don't think, I'm trying to decide, I think I'm going to write them twice, but not solve them all. 4 minus 2x equals 8. That's one possibility here. So it could be 4 minus 2x equals negative 8. See, I'm only changing the sign of that one little guy right there on the other side, not everything. Here, 3y minus 5 is equal to y, or it might be 3y minus 5 equals negative y. Again, 2 different equations, 2 possible answers when you solve those 2 equations. We'll solve this one. W over 2 plus 2 is equal to 10. That's one possibility. The other possibility, W over 2 plus 2 equals negative 10. Doing the same thing every time. I'm using the absolute values for one equation and leaving it alone. For the second equation, I'm removing the absolute values, making the second guy negative, or the guy that's over here by himself negative. Solve these equations, okay. Subtract 2 from both sides, and W over 2 equals 8. How do I get rid of divided by 2? Well, I multiply by 2. So W equals 16. That's one of the possible answers. Then I can do the other guy by Same step, subtracting 2, but I'll get a different answer because my 10 is negative. So W over 2 equals negative 12, or W equals negative 24. So once again, I have one absolute value equation, but that absolute value equation has two possible answers, and it always will. We'll always have to write two equations for it. Only one time when it doesn't, and that's this little guy left here on the bottom. 0 is the one number that isn't positive or negative. Think of the number line, and you recognize that 0 is in the middle, and it's only written once. All the other numbers are written as a positive and a negative. So this is the one guy that's only going to have one answer. It's just 2u minus 13 equals 0. Add 13 to both sides, divide by 2. You're going to get one answer, but only because it was just equal to 0. It can't be equal to the negative 0. I'm going to leave those up for you to answer. I think you can. They're solving two-step equations. Just remembering to write them twice for those absolute values. Okie doke, you are ready to do homework 7. Get busy. Come ask questions when you have them, please. See you next time.